In this video, I will teach you how to use the power of the Force to create a laser sound effect.
I created the laser sound effect you hear in the following scene using the force of gravity.
Hey you.
Hello there.
Those were the droids we were looking for.
I created the laser blast sound effect using a metal slinky while taking advantage of some cool properties of sound. So let's talk a little bit about waves to explain the scientific basis for the creation of the laser sound effect.
There are two categories of waves. Transverse waves, which include ripples in a pond, electromagnetic waves such as light, and seismic S waves. Longitudinal waves include sound waves and seismic P waves. To better understand how sound waves are used to create the laser sound effect, let's take a closer look at transverse waves to better understand the parts of waves and how waves can be measured. In transverse waves, the movement of the medium, that's the material a wave moves through, is up and down, and perpendicular to the direction the wave is moving. Notice how the green dots in the PhET waves on a string simulation move up and down as the wave moves from left to right. The parts of a wave include the crest, that's the top of the wave, and the trough, the bottom of the wave. The wavelength of a wave is the distance from one crest to the next. Amplitude is the distance from rest to crest or rest to trough. The midline in the PhET simulation is shown with the dotted red line. Frequency is the number of wave cycles that pass an observation point in 1 second. I'll count how many waves pass the ruler starting now. Ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that was 10 waves in 5 seconds, so that calculates to be a frequency of 2 waves per second, or 2 hertz.
Let's take a closer look at the parts of a sound wave.
Since the laser effect is created using sound waves, let's examine a longitudinal wave. In longitudinal waves, the particles move back and forth in a direction parallel to the movement of the wave. Notice the red dot moving back and forth to the left and to the right in the image. Longitudinal waves can also be called compression waves.
Let's take a closer look at the parts of a sound wave. An area of compression is where the particles are closer together. This creates an area of high pressure. An area of rarefaction is when the particles are more spread out. This is going to create an area of low pressure. Now the distance between one compression to the next, that is the wavelength of a sound wave. There's some other things that we want to know about. So longer wavelengths mean a lower frequency, and that's going to mean a lower pitch, whereas shorter wavelengths are going to mean a higher frequency. That's going to mean a higher pitch. Now we also consider amplitude. Amplitude is the trickiest of these with sound waves, I think. Amplitude is the maximum displacement of the wave from its rest position. Now let's talk about amplitude. Amplitude is what's going to determine the volume of a sound wave. If I have a higher amplitude, it's a louder sound. If I have a lower amplitude, it's going to be a softer sound. So how do we even measure amplitude? Well, let's define it first. Amplitude is the maximum displacement from rest. Now, where's rest? Well, in a wave, I have an area of compression where the particles are close together. It's not there. I have a position of rarefaction where the particles are spread apart. It's not there, okay? Now, the position of rest is going to be halfway in between where we find rarefaction and where we find compression. So the amplitude is going to work out, as we see in the image, to be 1/4 of the wavelength. So how do we use sound waves to create a laser sound effect? My friend Claudio at Dr. Mix created his using a Slinky and a pickup at his recording studio. Let's take a look.
Let's try and change the position of this. See if I put it here. This, ooh. Ooh. Perfect.
Wow, that was really cool. But what if you don't have the fancy recording equipment in your basement? I sure don't. So what I did is I took a metal Slinky and I went down to my basement and found the exposed metal ductwork that's part of my heating and cooling system.
All right, here we go. We're going to produce the Star Wars laser sound effect. So I want to show you how I set this up. So you can see that I just have a metal Slinky, and I just went ahead and I duct taped this to the ductwork in my basement with my heating and cooling system. So the Slinky is attached to the ductwork of my heating and cooling system. All right, now let me just set up this camera so I can show you how this is going to work. All right, here I'm raising the Slinky up to a high position. Here, because it's raised up, it has what we call gravitational potential energy. So that is the result of its height and its mass. Now, when I let it go, it's going to fall. That's going to convert that potential energy into a different form of energy called kinetic energy. Let's watch and listen to what happens here. What's happening that produces the sound is related to that conversion of energy. The energy conversion causes vibrations in the Slinky. Those vibrations are transferred into the ductwork, and the ductwork is acting as a resonance chamber. So it's amplifying the sound that we're hearing. And we're hearing that laser sound effect. As the Slinky vibrates, it's causing the air particles to also vibrate. Those vibrations of air particles cause changes in pressure. The changes in pressure in the air is sensed by your ears, and that sends a message to your brain that we perceive as sound. So let's take a listen to this again. Here we go. Potential energy, kinetic energy. Let's try a different variation on this.
To get the final version of the audio that I used in this video, I recorded the Slinky drop using an external microphone that I connected to my computer through the USB port. After I recorded that audio, I cleaned it up a little bit, and then I also altered the playback speed to give a more convincing sound. I think it turned out great, and I hope you enjoyed it. Thanks for watching. Amplitude is the trickiest of these with sound waves, I think. Amplitude is the maximum displacement of the wave from its rest position. Now the rest position is going to be partway between.
Ladies and gentlemen, boys and girls, children, all.